With this command and paste it and hit enter. It now asking your permission to continue, so just type yes. That's it. Some of the packages are already installed on my host, that's why it didn't take much time, but in your case it would take 1 or 2 minutes. After that, now let's do some workspace setup. So you may follow the below folder setup to work with this course. Let's create some empty folders in order to work with various packages and downloads and other kernel modules what we are going to write in this course. Go to your home directory and create a folder called workspace, and under that create another folder called LDD, which stands for Linux Device Driver. Under LDD you create some more folders like custom drivers, downloads, patches and source. Whatever the source we are going to download, like Linux source or U-boot source, something like that, we are going to keep that in source folder. If you get any patches, then we are going to keep that in patches folder, and if we download anything, any third-party software like root file system and other things, we are going to keep that in downloads, like toolchain and all, we can keep in downloads. And whatever the custom drivers you are going to write in this course, you are going to keep that in custom drivers folder. I mean, this is not a strict requirement for this course, but I would suggest you to follow this folder settings. Let me go back to the command prompt, and here I have created a workspace under my home directory, and I'm going to create one more folder, LDD. After that, let's go inside LDD. Here you have to create some more folders. Let's hit enter. That's it. And now let's move forward. So now we have to download the boot images and the root file system. Why it is required? In this course we are going to boot our board, that is BeagleBone Black, via the SD card, the micro SD card. So to boot the board we need boot images as well as root file system. First we are going to boot using the pre-built images, and after that we are going to update the kernel by cross-compiling the kernel source, which we are going to clone from the BeagleBone repository. That's why we are going to partition our micro SD card into two. The partition 1 holds boot images like MLO, U-boot and the kernel image, and its file system type will be FAT16. After that, the partition 2 holds the Debian root file system. We have to download the root file system as well. So the file system type of partition 2 could be ext3 or ext4. In this video I have also attached another file called pre-built images. Please download that and keep that file in your workspace under downloads. Under workspace, LDD and downloads, pre-built images, and after that just extract it. Right click and you can use extract here. Under this folder you get another folder called SD boot, and it has pre-built images. Let's not touch this, we'll cover this later. Now let's get back to the PPT. Let's move forward. Now you have to download the root file system. Download the boot images file attached with this video. We did that, and now visit this link and download the latest Debian image for BeagleBone Black. So just search for BeagleBone and head over to beagleboard.org, and here go to start and go to latest software images. from here you have to download the latest Debian images. At the time of recording this video, the latest one is Debian 9.9. You should download the one which is suitable for your board. So if you are using BeagleBone, then you should be downloading this Debian 9.9 2019-0803 SDIOT. This is the image for Pocket Beagle, BeagleBone, BeagleBone Black, and Wireless, and for so many other boards. So just download this and place it into your download folder. Let me click this and the download starts. So our next task is cross-compiler and toolchain download. To cross-compile Linux kernel, Linux application, and kernel modules to ARM Cortex-AX architecture, we need a cross-compiler. Because the SoC which is there on our BeagleBone Black hardware is AM335X, which is from Texas Instruments. This SoC is based on ARM Cortex-A8 processor of ARM v7 architecture. That's the reason why we need to have the cross-compiler, because we need to cross-compile all our Linux source code, the application, and the kernel modules. We are going to download this cross-compiler from linaro.org. What you have to do is just head over to your browser and just type in the Google Linaro toolchain and follow this link, linaro.org downloads. Refer to this section, latest Linux targeted binary toolchain releases. Just click on this binaries. So it will take you to this web page, and from here you can download. If your machine is 32-bit or if you are using 32-bit OS, then download this version, GCC Linaro 7.5.0 2019 i686_ARM Linux GNU EABI hf.tar.xg. So you have to download this. And if you are using 64-bit machine or 64-bit OS, then you have to download x86_64 ARM Linux GNU EABI hf.tar.xg. If you don't know whether if your machine is 32-bit or 64-bit, then just run this command uname-a. So if it shows x86_64, then it's a 64-bit machine. I hope you can do that and place this file in the downloads folder. I will see you in the next lecture. I hope you have downloaded these files. So your downloads folder should look like this. It should have pre-built images, the Debian image, and also the cross-compiler. After that, we have to install one more application, that is gparted application. This application will be used to partition our SD card. This is a graphical user interface application which we are going to use to partition the micro SD card. What you need to do is just go to show applications, and here just type software or soft and go to Ubuntu software. Here you have to search that application. So here is a search box and just type gparted. For you, you will see an install button here. Please install the software, and I'll continue in the next lecture. In this lecture, let's learn how to set up the toolchain path. Now, in the previous lecture, you have already downloaded the toolchain. We have to set the appropriate path. This will be helpful while compiling our source codes. You have to add the toolchain binary path to home directory's .bash rc file. These are the steps you have to follow. 1. You have to go to your home directory, open .bash rc file using vim or gedit tool. After that, the third step is copy the below export command with path information to .bash rc file. The command must be export path is equal to $path and colon path to toolchain binaries. And after that, save and close the .bash rc file. Let's head over to our downloads folder and extract this toolchain. So you can use extract here. Here you can see that it is extracting, so please be patient. Go inside this folder and here you find bin. Go inside that. You have to give this path in the path settings. For that, let's go to the command prompt and let's head over to that folder. Downloads, GCC Linaro. And just type pwd, and this is a path. Just select that path. That's it. And now come to your home directory, open .bash rc, and here you can see that I have already one export command. Let me first remove that. Come at the end, type export, and after that path is equal to $path colon, and now paste that path. That's it. After that, save and exit. Type the command source .bash rc. Just type 3 letters ARM and hit tab. Here you can see that the command prompt has detected our toolchain binaries. For example, this is a cross compiler GCC for our ARM Cortex A8 architecture, and this is an assembler. This is a debugger GDB, and this is a linker. These are the tools used to analyze the ELF file format, such as by using nm command you can analyze the symbols. Object copy you can use to convert ELF to a different binary format, such as .bin or .hex, like that. Object dump is used to dump the contents of the ELF file format, and various tools we can use to analyze the kernel modules or any file which is in the ELF format. Reproduce this at your desk and let me know if you face any issues. I'll see you in the next lecture. In the previous lecture, you did host preparation. In this lecture, let's look at some target preparation. Let's explore about some of the board components. We explored about this board in our previous course, isn't it? But I'll briefly explain about the board. The board is BeagleBone Black, and the heart of this board is an SoC from Texas Instruments. This SoC is from Sitara family of SoCs produced by Texas Instruments. The exact part number is AM225-8BZ something. And this SoC is based on ARM Cortex-A8 processor, which is of ARM v7 architecture of ARM. And apart from this SoC, this has onboard eMMC, that is a eMMC memory, and it has got micro SD card slot where you can connect the micro SD card. It has got USB host, HDMI interface, it has got Ethernet, and so many other things. You can boot this board through various interfaces. You can boot the Linux kernel through eMMC or SD card, USB, Ethernet, SPI. So various options are available. This board comes with pre-installed OS, the Debian OS on eMMC. And by default, this board boots via eMMC. That is embedded MMC. That's why when you give power to this board, the Debian OS, which is stored in the eMMC, runs. In this course, we will not be touching the eMMC memory of the board. Instead, we are going to install the Debian root file system and our boot images on the SD card, and we boot via the SD card, so your eMMC files will not get affected. Let's move forward. First, let's learn how you can supply power to this board. Very simple, you just need a mini USB cable. This mini USB cable actually comes with the board, so if it doesn't come with the board, then you may have to buy one. And this end actually goes to the PC and this end goes to the board. You have to connect this cable to the mini USB port, which you can find at the Ethernet slot side. That's how you power the board. And also you would need one more cable, that is serial debug cable. This is a very useful cable. This cable helps you to establish the connection between the computer and the target, that is the BeagleBone Black board. When Linux boots on the hardware, it actually emits the early boot messages on the serial pins. So the serial pins are exposed on the board. These are the BeagleBone's serial port pins. By using this cable, we can get those debug messages on our computer. Instead of this cable, you can also go for dongles, USB to TTL serial converter dongles. I would not suggest buying these dongles because this would make your setup more messy, because it doesn't come with a cable, isn't it? You have to arrange for the cables like jumper wires and all. That would make your setup more messy. That's why go for USB to TTL serial converter cable instead. This is a very low cost cable. You can get it for $3 to $4. Let's learn how to connect this cable to the board. Actually, you have to do a cross connection. That means TX must go to the RX and RX should go to the TX. Here you actually take the ground pin of the cable. The ground pin is black color. The ground pin of the USB to serial cable must be connected to the ground pin of the BeagleBone's J1 header. This is a J1 header. That is pin 1. And the TXD pin of the cable must be connected to the RXD of the BeagleBone's J1 header. That is pin 4. And RXD of the cable must be connected to the TXD pin of the BeagleBones J1 header, that is pin 5. You have to make use of 3 connections: ground, TXT and RXT. That's it. Very important point, TX must go to the RX and RX must go to the TX. Let's move forward. In the next lecture, let me explain you the boot sequence of the BeagleBone Black hardware. I'll see you in the next lecture. In this lecture, let's explore about the boot sequence of BBB. There are different boot sequences are possible, and you can alter the boot sequence. To alter the boot sequence, there is a boot button on the board, and the boot button is S2. If you don't press the boot button and if you just give the power to the board, then this boot sequence will be followed. That means the hardware will first try to boot from the onboard eMMC, that is embedded MMC. So if it doesn't find any valid partition, then it would check the next boot source, that is the SD card. If it doesn't find any valid boot images over there, then it would go to UART 0 and then it would try to boot from USB 0. That's the default boot sequence if you don't press the boot button. As I said already, the board already comes with pre-installed Debian OS on the eMMC. That's the reason whenever you give power to the board boots from the eMMC. You need not to press anything. Just give the power to the board, it boots. But in our case, we don't want to boot from the eMMC. Remember that. We want to boot from SD card. That's why we have to follow this boot sequence. You have to press the boot button during power up. Whenever you give power to the board, the boot button must be pressed. In that case, the first boot source becomes SPI, which would be invalid in our case. That's why the board tries to boot from MMC 0, which is nothing but micro SD slot. We have to keep valid partition and valid boot images on the SD card so that the board can boot from the micro SD card. In our case, this would be the boot sequence. But you need not to keep pressing the boot button S2 again and again during power up. There is one hack which I will cover in later lectures, that we can make our board boots from the micro SD card whenever we give power to the board. That we'll explore later. Actually, the boot button S2 affects a register called sysboot. Sysboot is actually a register, or it is a bit field of a control register of the SoC. A pressing or not pressing of S2 button actually affects the contents of the sysboot. That's what makes the board to select between different boot sequences. Here is a S2 button. This is a boot button. Just check your board. Near the micro SD card slot, you see one button. That is boot button named as S2. And you also see 2 more buttons. One is power button and another one is reset button. Let's understand what are the use case of this power button, reset button and boot button. Let's first understand what exactly is the use case of power button. By press and holding this button for 10 to 20 seconds, you can power down the board. Once the board is powered, if you want to power it down, then you need not to remove the USB cable which is connected to the computer. You can just do a long press on this power button about 10 to 20 seconds. So the board will go into the power down mode. Once you power down the board, gently press this button one time again. Your board will again power up. The use case is, instead of removing and connecting power sources to your board again and again, you can use this button to power down and power up. That's the use case. Next one is reset button. Pressing this button resets the board. But note that the boot sequence is not affected by the reset action. Why? Because the reset action will not affect the sysboot bits. You see a sysboot bits here? This is not affected by the reset. That's the reason the boot sequence will remain same. After that, boot button. You can use this button to change the boot sequence during power up of the board. In this course, I don't think we'll be using a power button more frequently. We may use it 1 or 2 times, not more than that. Most of the time we'll be just resetting the board. We'll not be using boot button more frequently as well. For some initial setup, we'll be using boot button and power button. And after that, you need not to use that button. I will guide you how to use these buttons, no problem. Let's move forward. So in summary, our board has got 2 important interfaces. The SoC can boot from the embedded MMC, which is of 4 GB, or our SoC can boot from external interface such as micro SD card connector. The micro SD card connector is called as MMC0 interface, and the onboard eMMC is called as MMC1 interface. As I said before, we will not be booting from MMC1 interface. We'll be booting from the MMC0 interface, that is the micro SD card. In the next lecture, I will cover booting from micro SD card interface, and I will see you in the next lecture. In this lecture, let's understand preparing our micro SD card for SD boot. First of all, we have to do micro SD card preparation. These are the steps you have to follow. Don't worry, I will guide you step by step. So for this exercise, you should have a micro SD card of 8 or 16 or 32 GB, and you need a card reader. First, you have to connect the micro SD card to the PC using card reader. And after that, just launch the gparted application which we installed in earlier part of the course. And you just make 2 partitions, FAT16 and ext4. Copy boot images on FAT16. This will be our boot partition. Anyway, we have already downloaded boot images, so you just have to copy. And then copy Debian root file system on ext4 partition. We have also downloaded the Debian images. We have to copy that. And after that, you have to configure some boot flags on the boot partition, so which I will show you later, don't worry. After all these steps, that is from step 1 to 7, you just have to unmount and remove the SD card from the PC. Just remove it. And then insert the micro SD card into BBB's micro SD card slot, and then boot from SD card interface. And now let's do these steps one by one. First, take out your micro SD card, connect it to the PC via the card reader, and launch the gparted application. Let's do this. So let me first launch the gparted application. Let's enter the password. Now the very important step is to select the device here. Very important, otherwise you may mess up with your hard disk. SDA is the hard disk and SDB is the SD card what I just connected. If you are not sure, then don't worry, just open the command prompt. You can just run the command dmesg. Here you can see that it says that the device file which is created for the SD card is SDB. It could be SDC, or something different in your case. But you have to run the dmessage, and you have to see the recent activities, and you have to select the appropriate device file. In my case, it is SDB. That's why you should be very careful here. I would select SDB, which is my SD card of 16 GB. It is already formatted into FAT32. Now we are going to create two partitions here. First, right click here and let's delete everything. Let's delete all partitions. I would select delete. 14 GB is available for us. Right click and create new. Select primary partition here. So the first partition is a boot partition and it should be FAT16. Select FAT16 here, and after that here you give the size. I would give a 256 MB or something like that, or 512, or even you can give 1 GB, no problem. Let's give a label for this partition. I would give boot, and make sure that this is primary partition. Click add. We created the first partition, boot, of 256 MB. Let's create another partition, new. You need not to change anything, so the remainings will be used for the next partition. Select ext4, make it primary partition, and label is rootfs. That's it. Add. And after that, click apply. If you click apply here, all the data of the SD card will be deleted and the SD card will be formatted into two partitions, FAT16 and ext4. If you are sure about that, then go and click the apply button here. Apply. Let's wait for some time. The operations have been completed. Close. And after that, you have to manage some flag for this boot partition. So to make it bootable, you have to set some flags. Select this partition and right click, manage flags, and select boot here and LBA, like this as well, LBA, close. That's it. After that, close this application. Now you can see that two partitions have been mounted, boot and rootfs. For some people, the partitions may not get mounted automatically. In that case, you would see two device files here. Like, in the dev directory, you will see SDB1 and SDB2. These are the two partitions what we just created. If you don't see these mounted directories, then no problem, just remove the SD card and connect it back. What I do is I just remove my SD card from my computer, then I just connect it back. And you can see that two partitions got mounted, isn't it? Boot and rootfs. Here we have to copy the boot images, and here we have to copy the rootfs. So that I would cover in the next lecture. Make sure that you complete up to here, and I'll see you in the next lecture. We are actually decompressing it, so just wait for some time. And if you want to understand what exactly this command does, just run man with that, manual xz, compress or decompress .exe files. What we did was just decompressing that file. Let's get into that folder. Let's go to the downloads here, and here we got, instead of xz, now we got .img. Now what you have to do is select this, right click, and just use this option, open with disk image mounter. When you use that, this image will be mounted in the file system. That you can see by running the command again, lsblk. Here it is. It is mounted here as rootfs. That img file is mounted in the file system at this mount point. Now we have to go inside this mount point and copy the contents of this mount point into our media, that is partition 2, from here to here. Let's do that. Let's go to media rootfs. This is the rootfs what we just mounted, and copy -a, select all, media, rootfs. This is our destination, and hit enter. It needs permission, no problem, so just use sudo. The root file system is the Debian one, and it contains lots of files which need to be copied. It would take some time, so please be patient. After that, very important command you have to execute, that is sync. In between, if you don't understand why I'm using these commands, then don't worry, just run man with that, man sync. It will show you the meaning of that command. Sync means synchronize cached writes to persistent storage. This is actually to flush the in-between cache data to the physical media. Because I will not be explaining the commands what we use in this course. For example, if you want to understand why did I use copy -a, just run man with that and you can see what is the meaning of -a or something like that. Let's go to boot here, and you can see that the files are copied here, and the root file system folder also contains the root file system, the Debian one. Let's get back to the PPT. So this step, configure boot and LBA flags on the boot partition. This is not step 7. Sorry about that. This should be step 5. We completed up to here. And now unmount and remove the SD card. Insert the SD card to the BeagleBone Black SD card slot. So to do this step, first remove the power from the PC. Disconnect the USB cable and then insert. After that, boot from SD card interface. I will cover this in the next lecture, and before that, I hope you can complete up to here. I'll see you in the next lecture. In the previous lecture, we prepared our SD card, isn't it? In this lecture, let's boot the BeagleBone hardware using the micro SD card interface. These are the steps you have to follow. First of all, make sure that your BeagleBone is not powered up. If you have connected it to the PC, please remove it. And after that, connect the serial debug cable between BeagleBone Black and host. This is actually optional step, but if you have that cable, then it's better to connect that, because by using that we can observe the early boot messages of the kernel. That is, you have to use this cable to establish a serial connection. Just connect this end to BeagleBone serial port pins and this end to your PC. After that, insert the SD card to BeagleBone. And after that, give the power to the board using mini USB cable. Just give the power. And when you give the power, what happens? The board boots by using the images which is there in the eMMC, remember. Let it boot, no problem. That's the default boot. Let it boot. Then what you do is press and hold the boot button, that is S2. After that, press and hold the power button S3 until the blue LED turns off and turns on again. If blue LED doesn't turn on, gently press the power button. That means you are doing a power down of the board by pressing the S3. Then gently press the power button. When you do that, the board powers up again. After around 2 to 5 seconds, you release the S2 button. That's how you change the boot sequence. In this case, the board will boot from the micro SD card. Let's do these steps. First of all, let me open the command prompt, and I have connected my serial debug connection. Just run the command dmessage. Here you see some logs which is related to our USB serial converter. That is the cable what we connected for our serial debug connection. It shows that the converter is detected. In my case, the converter is this one. If you just Google this, so basically it's a USB to TTL converter chipset from Prolific Technology. If you are using some different cable, then the chip may be different. It could be from FTDI or it could be from some other manufacturer. In that case, it would show some other vendor here. That's not an issue. But you should see something like this. The converter is attached to a device file, that is TTY USB 0 or TTY USB 1, something like that. That means we are going to establish the serial debug connection over TTY USB 0. So that means the host is going to communicate with the board over serial communication over this device file, that is TTY USB 0. You should see something similar. And after that, let's use Minicom to observe the serial data. For that, just run sudo minicom -s. After that, go to serial port setup here. And here, press the key A. And here you can change whether it could be TTY USB 0, USB 1 or 2 or something like that. So in my case, it is USB 0. Then type enter to exit from here. Enter. After that, if you want to change the baud rate, that is BPS, you can press the key E. And from here, you can select the bits per second, parity, and data or something like that. For example, if I want to change the baud rate to 9600, then I would just press the key C. You can see that the baud rate got changed. But we are going to use 115200, that's why I would press the key E. Hit enter to exit this. And after that, make sure that hardware flow control no and software flow control no. If you want to make yes, then you should type that letter. For example, if I want to enable the hardware flow control, then I would press the key F. It becomes yes. But in our case, it should be no. So I would press the key F again to make it no. This should be your setting. And then press enter to exit this menu. After that, go to this option, save setup as default, and press enter. After that, exit. We are in the Minicom. Now Minicom is a serial port application in order to trace the messages which are coming over serial interface. If you want to exit from the Minicom application, it is very simple. You have to press Ctrl A. Just press Ctrl A, and after that X. You can leave the Minicom like this. So I would press no here. If I press yes, what happens? The Minicom terminates. And if you want to again open the Minicom, then either you use sudo minicom -s or just sudo minicom, because you have already saved the setup as default. That's why I just type sudo minicom for the next time. Let's do these steps. Insert the SD card to the BBB and give power to the board using mini USB cable. Let me do that. Let me give power to the board. Now you are seeing some boot messages here. So you may see something like this, or you may not see something like this. It doesn't matter what you see here. Go to the next step. The next step is very important. You have to press and hold the boot button and then press and hold the power button until the blue LED turns off and turns on again. And once the blue LED turns on again, release the S2 button after 2 to 5 seconds. Let's do that. I am now press and holding the S2 button, and now I am long pressing the S3 button. I am waiting for the power down. You can see that it started booting. Now leave the S2 button. You can see that the board is booting from the SD card. We got the BeagleBone login. The board has successfully booted from the SD card interface, and this is a login name and this is a password. Let's type Debian and the password is temppwd. We successfully logged in into our BeagleBone Black hardware. Just run uname -r and you should see this number. This is from the pre-built image of what we have used, 4.4.62. So you also should see the same number because you also booted from the pre-built images which I have given to you, right? We have to do one important step. Here, to boot from the SD card, we played with the buttons like S2 and S3, but that's a tedious process. Let's skip doing that. But still, our board should boot from the SD card. For that, let's do one small hack. What we can do is let the board use this default boot sequence, no problem. First, it checks MMC1 and then it goes to the MMC0. Here, what we can do is in the eMMC, let's do some changes to the boot images. Let's invalidate the boot images. If you do that, the board first checks for the eMMC and it fails because we have invalidated the boot images. That's why the next source in the boot order is SD card. That's why the board will boot from the SD card. That means we have to do some changes to the eMMC memory. If you do this, then we need not to play with S2 and S3 button. So you just give power to the board, it boots from the SD card. Let's do that. Just follow what I do now. Go to the command prompt and make sure that you logged in into the BeagleBone. Create one mount point because we have to mount the eMMC partition now. Just first type the command sudo -s, enter the password temppwd and create one folder in media folder. Let me call it as temp1. This is the mount point. Now to mount the partition, you have to use the command mount. Mount, the partition is dev mmc block 1, mmc block 1 p1. Why? Because as I explained before, MMC1 interface is for eMMC and MMC0 interface is for microSD card. That's why you have to use MMC block 1 P1 partition 1. This is MMC block 1 partition 2. This is a boot partition of the eMMC, and the mount point is what we created, media temp1. It throws some error or some warning, that's okay. Let's get into the mount point, media temp1. These are the boot images of eMMC, remember that. Here, just change the name of this MLO. Use the move command, change MLO to MLO dot backup, something like that. We just alter this name. You can always go back and you can fix this to MLO later. Now what happens? When you do a default boot, the board first checks for the eMMC. It first checks for the file called MLO. Since MLO is not present here, it goes to the next boot source in the boot order, and the next one is SD card. We just changed this name, that's it. And after that, you have to execute the command sync. After that, you have to shut down -H now. The board will be powered down. So you can see that your board went to power down mode. Just press the power button, that's it. Or you can remove the cable from the PC and connect it back. So I would do that. I would just remove the USB cable from the PC and I connect it back. Now you can see that you need not to press any S2 or S3, it boots from the SD card. That's great. And in the next lecture, I will cover Linux kernel image update. I will see you in the next lecture. Of the eMMC. For example, if I just run the command lsblk here, now you see here mmcblk0, this is nothing but your SD card, okay, which has got two partitions, P1 and P2. And this is the onboard embedded MMC, okay, eMMC. The newer eMMC flash images of beagleboard.org, it actually creates only one partition here, mmcblk1 P1, okay, you don't see P2. And you cannot locate the MLO in this partition. Let me mount that, okay, mount dev mmcblk1 P1. Let's mount to some mount point. And here if you go inside boot, okay, you don't see MLO here. That's because the newer eMMC Flasher Debian images of beagleboard.org, it actually creates only one partition, okay, mmcblk1 P1, and this is of type ext4, and it doesn't copy the boot images such as MLO and U-boot into this partition. So it actually creates 1 MB of MBR, master boot record. So, and it stores the MLO and U-boot into this MBR. Actually, there is no file system on this MBR. You cannot mount this, okay. These MLO and U-boot are hard coded onto this MBR. And now if you want to force your BeagleBone hardware to boot from SD card by default, then you have to erase this MBR. Okay, so don't worry, you can recover it later, no problem. I will teach you how to do that. Now we are going to erase this MBR. Let's get back to the BeagleBone. So go to the BeagleBone command prompt here, and let's first unmount this partition. Okay, let's use the dd command to first take the snapshot of the MBR. Let's save that into some file, okay, so because we want it later to recover it. So that's why I'm going to use the dd command. Input file is equal to dev mmcblk1, and output file is equal to, let me call it as emmcboot.img. So from here we are copying some data, that is MBR, into this file, okay. This is a local file, and the block size is equal to 1 MB we are copying, and count is equal to 1 time. Right, hit enter. Alright, so now you see here this file gets created which has the snapshot of the MBR. So now we are going to zero out the MBR. Let's again use the dd command. dt input file is equal to dev 0, output file is equal to dev mmc block 1. Okay, and bs is equal to 1 megabytes, count is equal to 1. You zeroed out the MBR. Now let's test this. So what you do is remove the power from the BeagleBone Black hardware. Okay, you just disconnect the USB cable from your computer. I'm going to do that. Okay, I just disconnected the power, and after that connect the USB cable back to your computer to give power to your board. Okay, right, so now here it is. Now you see here, now you can see that the board is booting from SD card. Okay, it is not trying to boot from the eMMC. So this way you can force your BeagleBone Black hardware to boot from SD card by default whenever you give power to the board. Now let's see how to recover the MBR. So let me just log in. Alright, so I'm again going to use the dd command, input file. Okay, the input file will be eMMC boot.img, so what we saved earlier. Okay, and output file is equal to dev mmc blk1, and bs is equal to 1 megabytes, count is equal to 1. So we just recovered the MBR. Now let's test this. Okay, alright, so now just remove power from your BeagleBone Black hardware by disconnecting the USB cable and connect it back. Right, here it is. Now it is booting from the eMMC. Alright, so that's how you can force your board to boot from SD card by default whenever you give power to the board. Okay. So throughout this course we'll be using SD card boot. Okay, so we'll not be using any contents of the eMMC. Alright, so I hope you can reproduce this at your desk, and I'll see you in the next lecture. The next step is Linux kernel image update. First of all, why this step is because currently I have given you the pre-built image of the kernel, and the kernel version is 4.4.62 or something. Whenever you build your kernel module or device driver, then you have to build against a kernel source which you are using on the target. That is very important. So that's the reason why you should have the kernel source present on your host computer. In future videos, I will show you how to download the kernel source, configure it, and generate a kernel image. Then update the SD card with a new kernel image what you generated. For that, you have to follow some steps. First of all, you have to clone the latest stable kernel source from the BeagleBone's official GitHub repository. Then you have to compile and generate the kernel image, and then you have to update the SD card with new kernel image, and you have to boot again. I will cover these steps step by step. First, let's go to the BeagleBone's official GitHub repository. Let's search BBB Linux source in Google. Here you click on the GitHub beagleboard.org, then here click on Linux. It would take you to BeagleBone's official GitHub repository. Here you can search for the branch 5.10.168. Then select this branch. You can use this branch, no problem. Then click on code. Here you can directly download the zip folder of the source code, or you can just copy this link. Go to your command prompt. I'm in the host now. Let's get into the source folder what we created. So here you first do git init, and after that do git clone and paste the URL what you had copied and give the name linux_bbb_5.10 and then hit enter. This would clone the Linux code onto your computer, and it would take some time, so please be patient. I will continue in the next lecture. Hey, welcome back to the lecture. So in the previous lecture, I hope you have downloaded the Linux source code from the official GitHub repository of BeagleBone. And now let's configure and let's generate the Linux kernel image by compiling the Linux source code what we downloaded. For that, we have to follow the kernel compilation steps. These steps I have already covered in our earlier course, but as I said, if you have not taken that course and if you have come directly to this course, then no problem. You can still follow these steps. That's why I am explaining these steps very briefly. First step would be just run make dist clean. This would remove all temporary folder, object files and images generated during the previous build. This step, remember that deletes the .config file if created previously. Basically, this step is not required because we have not done any previous build. We are doing a fresh build. That's why this step is not important. Step 2 would be create a .config file by using default config file given by the vendor. For that, we have to run the command make arch is equal to arm, the default config file of your board. In our case, the default config file would be bb.org_defconfig. After that, the third step is menu config. This step is optional. Run this command only if you want to change some kernel settings before compilation. We may do this a little later during our course, but not now. You need not to execute this menu config command. And the step 4 is compilation, the kernel compilation. This stage creates a kernel image uimage. Also, all the device tree source files will be compiled and DTBs will be generated. You can just copy paste this command on your command prompt. So I have attached a text file with this video from which you can get all these commands. After that, step 5 is building loadable modules .chaos. It is a step to build the kernel modules. That's why we have to use the command modules. After that, we have to install the generated modules in the previous step. That's why we have to use the command modules install. This step installs all the generated .ko files in the default path of the computer. So don't worry, I will guide you with all these steps, and after that we have to update the kernel image. Let's see that later. Let's head over to our command prompt. So we downloaded the Linux source code and let's get into that folder. So this is the Linux source. First just do make arch is equal to arm dist clean. After that, we have to generate the .config file by running the board's default config file. The board default config file you can get in arch arm configs. Here you get the default config file for various boards. So for the BeagleBone, you just do ls-l b star. For the BeagleBone, you can use this bb.org_defconfig. Let's apply that. Just run make arch is equal to arm bb.org_defconfig. You can see that the .config is generated. After that, you can do menu config if you want to change any settings, but we don't want to change any settings. That's why we can skip this command for a time being. Let's compile the Linux source. For that, the command is this one, make arch is equal to arm. Cross compiler, you have to mention cross compiler is equal to arm linux gnu eabihf, and after that uimage dtbs load address, you have to mention the load address 0x80008000. After that, the build flag -j4. Let's hit enter. It will definitely take 10 to 15 minutes based on your system laptop performance. Let's hit enter. The Linux kernel compilation is completed, and you can see that we generated the kernel image, that is uimage. And the next step is building kernel modules. Let's do that. For that, you use the same command, just delete all these things. Modules -j4. This command will build all the kernel modules of the Linux source tree. Let's hit enter. This would take some time. Please be patient until the compilation completes. Now the kernel module compilation is over. Let's run our final command, that is modules install. This step installs all the generated .ko files in the default path of the computer, and the default path is root lib modules. Used to run this command, sudo make arch is equal to arm modules install. Let's do that. Sudo make arch is equal to arm modules underscore install. This basically a command which copies all the .ko files into the lib/modules folder. It should finish quickly, so this is not a compilation. Here you can see that the installation is completed. You can go to the directory lib modules path. You can see that this is the latest one created, 5.10.168, which got created now. So you should see this folder in your system, and the modules install command is created this folder, and it has copied all the .ko files. We have completed all these steps required to carry out the kernel compilation and to generate the module. In the next lecture, let's update the kernel image on our BeagleBone Black hardware. I will cover that procedure in the next lecture. So we completed our kernel compilation and we generated the new kernel image. And also we compiled the kernel modules of the new Linux kernel version. Now we have to update those images and the kernel modules in the BeagleBone Black hardware. That's why we have to follow this procedure. First thing what we have to do is copy uimage to the board and then update the boot partition of the SD card. Basically what you need to do is you should take out your SD card, connect it to the PC and copy new image to the boot partition of the SD card. And also copy the DTB file, that is am335x-boneblack.dtb. This file to the boot partition of the SD card. After that, copy newly installed 5.10.168 folder to the board's lib/modules folder. So when we ran the command modules install created this folder in our system's lib/modules path, right? So that folder we have to copy into the root file systems of the SD card under root lib/modules path. And then remove the SD card from your PC and connect it to the BeagleBone and just boot again. So we should see BeagleBone boots with a newly updated kernel image. So let's do that. I'm going to connect SD card to my system. Here we have older image, so let's rename that. Rename it to something different like uimage 4.64 something. And also this one, am335x boneblack.dtb file, rename it to different name like _old.dtb. So I'm in the host in the Linux source tree. Let's go to the folder arch/arm/boot. Here is the U image. Copy that U image to the SD card. Now let's copy U image to root media slash your username slash boot partition. After that, go to this DTS folder. Here we can see that DTS files for various boards. For our BeagleBone Black, just type ls-l am335x* and hit enter. Here we can see the DTB files, that is am335x-boneblack.dtp, which is for our BeagleBone Black hardware. Let's copy this file. So let's copy this into boot partition of the SD card. We can see in the boot partition of the card the newly generated DTB file and U image copied successfully into boot partition of the SD card. And after that, go to lib/modules. Here you have to copy this folder. Just run the command cp-a, select this folder 5.10.168 and copy this file to /media username rootfs lib/modules. Hit enter, and that's copied. Then run the command. Let's cross check the rootfs and lib and modules. Here we copied 5.10.168. Fair enough. Now just unmount it, remove the SD card, connect it to the BeagleBone and boot again. Let me first open the Minicom. Now let me power up my board. Here it is, it's booting. Here we have to log in. Debian, password is temppwd. After that, run the command uname-r, and you can see that the kernel image is now updated to 5.10.168. Complete up to here, and I'll see you in the next lecture.